Good morning, everyone. Welcome to our financial management class. Last week, we studied how to evaluate firms' financial health using different financial ratios. Today, we will move on to our next section and unlock a very core concept in finance. It's called the time value of money. By the end of this section, you will be able to define the time value of money, calculate future value and present value, and finally, apply these formulas to real-world scenarios. Now, let me start with a very simple question for you, assuming that you have two options. Option A, you receive $100 today. Option B, you receive $100 next year. Now, the question is, which do you prefer? Please raise your hand if you prefer $100 today and tell me why. Good. I heard answers like, I can use it now. Price go up. I can put it in the bank. Very good. Exactly. These are the key ideas. This leads us to a very important concept in finance, time value of money. This means a dollar today is worth more than a dollar in the future. This is true because of two main reasons. First, inflation. One simple example is that you can buy a coffee today with $1, but probably not for next year. Second, opportunity cost. If you put $10,000 in the bank deposit for 1 year at a 2% interest, it yields about $200. You can earn $200 after 1 year. Your money has earning potential. So now you know that they are different. And here is the real questions. How can we compare money at different points in time? Let's say option A is still 100 for today, but option B is no longer 100. It's $110. So which option is better now? How can you compare different amounts of money at different points in time? Think about it. To compare them, we need to bring them into the same point in time. That means we can now move money forward. That means we convert $100 to the future, which is 1 year from now. Or we move the money backward. We cover $110 to the value right now. Right? Do you agree with me? But how do we do so? Let's move on to the next slide to see. Okay, so suppose you invest 10,000 US today. The return is 8%. How much will you have in 1 year? These values equal the return you will get, which is $800 and plus your capital, $10,000. So totally, in 1 year, you will receive $10,008. The $10,008 amount here, we call it future value. Is the value of money in the future. And the initial $10,000 is the present value. It's the value of money today. And the 8% here, we call it rate of return. Please also note that the 10,800 here also equal 10,000 multiplied by 1 plus 0.08. And from here, we can derive a general formula for calculating the future values of today's cash flow. Future values equal present value multiplied by 1 plus R. This means we take today's values and grow it forward. This process of moving forward in time is called compounding. All right, let's think about the opposite directions. Suppose instead, I tell you this. You will receive $10,000 in 1 year. How much are you willing to pay for that for today? Should it be 10,000 and why? Now, please scan this QR code and give your answer in Slido. All right, I have found that all of you have given your answers, and the majority choose less than 10,000 because of the time because of the time value of money. This is wonderful. You have caught the call. Because money today can earn a return, so 10,000 in the future must be worth less today. And to find the present value of future money, we reverse the compounding process. In general, we write present value of future cash flow going to equal future values divided by 1 plus R. This process is called discounting. We move backward in time and we discount future value to present value. Please note that R now has another name. It's called the discount rate. And this part here is called discount factors. So now, let's go back to our example questions on this slide. We plug in the numbers with a 8% discount rate and find that the present value is $9,259. So receiving 10,000 in 1 year is equivalent to about $9,259 today. Let's do a quick check with a practice. Please scan this QR code to answer the questions in the following two practice. First practice, if you invest $10,000 at a rate of 12% interest for 1 year, what is the future value of your investment? All right, congratulations to those who choose answer A. The correct answer is $11,200. To find future value, we take present value and multiply by 1.12. Now, let's move on to our second practice. If a project promises to pay you $11,424 in a year and at an interest of 12%, what is the present value of this project? Wonderful for those who choose answer A again. To find the present value, we discount the future value back, which gives us $10,222. All right, we have just focused on a project that lasts for 1 period only, which is in our previous example is 1 year. What if the project lasts more than 1 period? Let's say in our previous example is not 1 year, but is 3 years and 5 years. For investment lasting for more than 1 year, we use an exponent for time. For future values, we raise 1 plus r to the t power, where t represents the time period. The return rate is compound not only for 1 year, but also for 2, 3, and more years, depending on the project's duration. For present value, we reverse. We discount future value by dividing by 1 plus r raised to t power to account for the time period. Okay, So now you understand the mechanism and the formulas. Let's try to apply these formulas with a mini case. In this case, imagine that you are an investor who is facing two choices. Option 1, you take a project that pays you 10,000 today. Second, you take a project that pays you 12,000 in 3 years. Assuming that the discount rate is 5%, which one is a better choice for you and why? Please form a group of 3. First, I want you to calculate the present value of option B and compare it with option A. Second, you calculate the future value of option A and compare it with option B. Third, identify where the conclusions from these two approaches are the same. You have 6 minutes and you may begin now. And finally, when you finish, please write down the choice in the Slido link here with the QR code. Okay, as I received all of the answers from you, let's review the result together. To compare these two options vary, we must look at them in the same time period. Let's say we discount the future values back to the present value. So we're going to discount option B, 12,000 back 3 years. We divide 12,000 by 1 plus 0.05 raised to 3. Why is 3 here? Because we have t here equals 3 years. The project lasts for 3 years. The present value is 10,336 and 66. Because 10,366 is greater than 10,000. That offered by option A. So option B create more wealth. Okay, so how about if you calculate the future values for option A? It's gonna generate the similar conclusion. Option B still create more wealth in the future. Okay, so congratulations to those who got it right and choose option B. Okay, to recap what we covered today, look at this time travel metric. We move forward in time. We are looking for futures values using compounding process. Future values equal present value multiplied by 1 plus r raised to t periods. When we move backward to today, we are looking for a present value using discounting process. Present values equal future value discounted back by the discount rate. Okay, looking back our goal, I hope that you can now successfully define the time value of money. Calculate the future values and present value. And finally, apply them to make a smart investment decision. So far, our focus today is only on one cash flow for a project. Next week, we will handle multiple cash flow, and I will introduce a new concept of annuities. Please read the second half of chapter 4 before our next class and review today's key terms and finish the exercise related to the content. Finally, are there any unclear terms? If you have any questions about English vocabulary, formulas, or applications we use today, please come to chat with me. Thank you all for a great class.